Hi, hello everyone, welcome to today's session. In today's session we are going to see about necessity of grinding angles, lathe cutting speed and feed, coolants and lubricants. Let's move into our topic, necessity of grinding angles. Objectives of this topic is, at the end of this topic you shall be able to name the different angle of the tool, state use of the each angle, state the effect of the incorrect angle. Let's see about the approach angle. This is also known as side cutting edge angle. This is ground on the side of the cutting tool. The cutting will be oblique while cutting. The angle ground may range from 25 degrees to 40 degrees, but as a standard a 30 degrees angle is normally provided. The oblique cutting has the advantages over the orthogonal cutting, in which the cutting edge is straight. Let's see about trail angle. It is also known as end cutting edge angle, and is ground at 30 degrees to a line perpendicular to the axis of the tool, as illustrated. The approach angle and trail angle ground will form the wedge angle of 90 degrees for the tool. Let's see about top or back rake angle. The rake angle ground on a tool controls the geometry of chip formation. Thereby, it controls the cutting action of the tool. The top or back rake angle of the tool is ground on the top of the tool, and it is a slope formed between the front of the cutting edge and the top of the face. If the slope is from the front towards the back of the tool, it is known as a positive top rake angle. If the slope is from the back of the tool towards the front of the cutting edge, it is known as a negative back rake angle. The top rake angle may be ground positive, negative or zero according to the material to be machined. Negative top rake tools have more strength than tools with positive top rake angles. Let's see about side rake angle. A side rake angle is the slope between the side of the cutting edge to the top face of the tool widthwise. The slope is from the cutting edge to the rear side of the tool. It varies from 0 degree to 20 degrees, according to the material to be machined. Let's see about front clearance angle. It is the slope between the front of the cutting edge to a line perpendicular to the axis of the tool drawn downwards, which is known as the front clearance angle. The slope is from the top to the bottom of the tool, and permits only the cutting edge to contact the work, and avoids any rubbing action. If the clearance ground is more, it will weaken the cutting edge. Side clearance angle. The clearance angle is the slope formed between the side cutting edge of the tool, with a line perpendicular to the tool axis drawn downwards at the side cutting edge of the tool. The slope is from the top of the side cutting edge to the bottom face. The side clearance angle needs to be increased when the feed rate is increased. Let's move to our next topic, lathe cutting speed and feed. Objectives of this topic is, at the end of this topic you shall be able to distinguish between cutting speed and feed, comparison for HSS and carbide tools, point out the factors governing the cutting speed, state the factors governing feed. Let's see about cutting speed. Cutting speed is the speed at which the cutting edge passes over the material, and it is expressed in meters per minute. V is equal to pi dn by 1000 meter per minute, where V is equal to cutting speed in meter per minute. Pi is equal to 3.14. D is equal to diameter of the work in mm. N is equal to rpm. Let's see about factors governing the cutting speed. Finish required. Depth of cut. Tool geometry. Properties and rigidity of the cutting tool and its mounting. Properties of the workpiece material. Rigidity of the workpiece. The type of cutting fluid used. Let's see about feed. The feed of the tool is the distance it moves along the work for each revolution of the work, and it is expressed in mm per revolution. Let's see about the factors governing the feed. Tool geometry. Surface finish required on work. Rigidity of the tool. Let's compare the HSs and carbide tools. Ferrous tool material have iron as their chief constituent. Non-ferrous tool material do not have iron. Alloying tungsten, chromium and vanadium to high carbon steel, high-speed steel tool material is produced. Carbide cutting tools can retain their hardness at very high temperature that of high-speed steel. HS's tool cutting speed is low. Carbide tool cutting speed is high. HS's is a solid tool. It is a braced tool bit and throw-away tool bit die to brittleness. HS's tool cost is low. Carbide tool cost is high. Let's see our next topic: coolants and lubricants. Objectives of this topic is, at the end of this topic you shall be able to state the properties of coolants and lubricants. State the purpose of using a coolant, otherwise called as cutting fluids, and lubricants. Name the different cutting fluids. Let's see about coolants, or called as cutting fluids. Coolants, or cutting fluids, play an important role in reducing the wear of cutting tools. Coolants, or cutting fluids, are essential in most metal cutting operations. A good cutting fluid should have the following properties: good lubricating quality, rust resistance, stability both in storage and in use, resistant to separation from solution after it is mixed with water, transparency, relatively low viscosity, non-flammability. The following are the main purposes of cutting fluids: to cool the cutting tool and the workpiece, as heat is generated during cutting operation, because of friction between the tool and the workpiece. To cool the cutting edge of the tool and to prevent any wear on the tool. To prevent the formation of chip welding. To give a good cutting efficiency to the tool. To give a good surface finish on the job. To act as a lubricant for the tool and the machine. Let's see about types of cutting fluids. The different types of cutting fluids are: soluble mineral oils, straight mineral oils, straight fatty oils, compounded or blended oils, sulfurized oils. Let's see about lubricants. A film of cooling medium, with high viscosity is applied, between the mating parts of machine, which is known as a lubricant. A lubricant is a substance having an oily property available in the form of fluid, semifluid, or solid state. It saves the machine and its parts from corrosion, wear and tear, and it minimizes friction. Let's see about the purpose of using lubricants. Reduces friction. Prevents wear. Prevents adhesion. Aids in distributing the load. Cools the moving elements. Prevents corrosion. Improves machine efficiency. Let's see about the properties of lubricants. Viscosity, oiliness, flash point, fire point, pour point, emulsification and deemulsibility are the properties of lubricants. Let's test our knowledge we gained from our today's topic. Try to answer the following question. How the end cutting edge angle of tool is otherwise called as? Option A. Approach angle. Option B. Trail angle. Option C. Top or back rake angle. Option D. Side clearance angle. Your time starts now. I think you are right. The correct answer is option B. Trail angle. We have come to an end of this session. I think you have gained a plenty of knowledge from today's topic. In this week we have seen nomenclature, tool selection, necessity of grinding angles, lathe cutting speed and feed, coolants and lubricants. Thank you. For queries, visit www.nemelearningonline.in/moodle.